How do you choose an LLM for your project? Hey everyone, my name is Velin, and in this video we're going to answer the question of how you can evaluate your LLM systems and RAG applications. First, we're going to start with why classical machine learning metrics don't usually work. Then we're going to have a look at some of the classical NLP metrics. And finally, we're going to venture into a bit more interesting part of LLM evaluation, and that part is usually called AI evaluating AI. So in essence, we are going to be using an LLM to critique or evaluate the responses of other models. Let's get started. If you want to follow along, there is a complete text tutorial that is available for MLXpert Pro subscribers, and it is within the bootcamp and then LLM evaluation. Here you can find the complete text tutorial along with some explanations on how you can essentially redo or reproduce the results that I'm showing throughout this video, as well as a link to the Jupyter or Google Colab notebook. So if you want to support my work, please consider subscribing to MLXpert Pro. Thank you. Let's say that you want to compare the generation responses from Llama 3 and Gemma, and you want to compare the results based on your custom dataset. So what can you do? In such situations, originally, we had some classical ML evaluation techniques when we were essentially trying to evaluate some regression models and classification models, and we'll see why this doesn't work out in LLMs. Then we are going to have a look at some of the LLM evaluation techniques, some naive evaluation implementations, and then we are going to have a look at some of the available tools that you can use in order to evaluate your LLMs. And then I'm going to show you some of the metrics that I routinely use when I'm trying to pick the best possible LLM. So when we were doing some classical ML evaluations, we had originally just an output of a number or a category, and we were expecting those numbers to be, or outputs to be, in a certain form. And then we had very nice subsets of metrics that we can use for various tasks, such as regression classification. And yeah, you probably know some of the metrics, such as accuracy, F1 score, recall, precision, etc. Then some of the tasks required some regression metrics, such as mean squared error, root mean squared error, etc. And we can actually use some of those metrics in order to evaluate your LLMs, but only on a subset of the tasks that are available when doing some LLM AI tasks. And those metrics are pretty much very bad on tasks such as question answering, summarization, etc. So for those particular tasks, we had different approaches, and one very bad approach is to use just human evaluators. This is very slow and requires a lot of budgeting in order to do some serious evaluation of models. And then we had some metrics such as blue, rouge, etc. in order to do some evaluation on the text that the models were actually outputting. But we had an easier or better approach to do that, and this is to actually use a very strong LLM to evaluate other LLMs. And in this case, we are essentially using an AI model to critique another AI model. And in these cases, you are pretty much recommended to use some pretty strong models in order to critique the outputs of different models. And one really important thing to keep in mind when doing such tasks is to essentially remember that we have these observations, which essentially say that if you're evaluating the responses of a model with the same model, this model will probably have a strong bias to say that the scores of this model are pretty good compared to other models. So keep that in mind. And this is a tweet: LLM evaluators recognize and favor their own generations. This is a paper on Archive, which you can have a look at, but it essentially says that if you're using the same model for critique and output of generations, you're going to be expecting a favorite of this model. So what can we do in order to use an LLM to evaluate the responses of an LLM, one very naive approach would be to just generate a question, use the model to generate an answer, then ask another model to critique the answer of the first model and scale and respond with the scale from 0 to 10. And then when we redo this same thing for a lot of examples, essentially you can create a report or an overview of the general performance of this model. But this is, let's say, not a very correct approach if you have, let's say, a more complex application. This simple scoring will not give you a better look at the different components that you have. For example, you can have a rack application and you can have a component that is trying to find the context, or so this will be the retriever of the rack application. And if this retriever is not doing a good job, this scoring will not be appropriate since you failed with the context itself. So I've took a look at a lot of tools that are available. For example, Ragas is a really cool one, Giscard or Giscard, another cool one. But I wanted something that was pretty much using just pure metrics, and I was able to evaluate those metrics on my own. And in this way, I could essentially implement these metrics within my project without running the complete framework and tooling that were required by these libraries. So in this case, I am pretty much using the Deep Eval framework. The Deep Eval framework is an LLM evaluation framework that is open source on GitHub. And I really like this project since it offers a lot of the required evaluation metrics that you might need. Those are listed here. It offers a very nice documentation, but the most important part was that I can essentially import some metrics and use those metrics in a standalone manner. So what metrics are pretty much the most used ones? I really like the hallucination metrics. This metrics essentially is trying to have a look at the output of the model or the answer of the model, compare that with the context, and say whether or not the answer of the model is something that is not available within the context. So really important one. Then we are going to have a look at the faithfulness metric, which essentially is a way to have a look at whether or not the context contains the answer. And then we are going to have a look at answer relevance. And this one is essentially pretty much the same as the faithfulness, but it checks for correctness or how close the answer matches the question. And this is essentially the diagram that we're going to use in order to evaluate our model. So first, this will be our user. The user is going to give a context and a question to our LLM or our rack application. Then we're going to take some response. And from our dataset, we're going to get the true response along with the response that was generated by the rack. And then we are going to be passing in this to the critic model, which again can be completely different compared to what we used in our original system. And essentially, this critic will use some of the metric or all of the metrics to provide us with some score in order to tell us whether or not this answer is even any good. I have a Google Colab notebook in which I'm installing the latest versions of the Grok API client, the datasets library by Hugging Face, and the Deep Eval framework. Next, I'm adding all of the required imports for us and setting up the Grok API key. I don't want to send any telemetry to Deep Eval. And finally, I'm setting the critique model, which is going to be WAMA 370B. If you are using a lesser model, for example, WAMA 38B, you might have a lot of trouble with doing the metrics since they expect a certain output. And the 8B model is not that great in essentially trying to give you the correct output, for example, JSON, etc. So I've tried that and these models are not good enough. So I would highly suggest that you use a strong model for your critique. Then I'm going to be loading this dataset, financial Q&A 10K. Essentially what this has is, for example, a question, this is a financial question and answering dataset, and it has an answer, and then it has a context from which the answer should be derived. So this is essentially the setup that we are going to be using. And if you have a custom dataset, this is one way to essentially organize your dataset in order to evaluate the LLMs that you're going to have. Next, I'm also going to be subsetting a sample of this dataset, since pretty much the critique model is going to be pretty slow, even though we are using the Grok API. And I've tried to run, for example, about 100 examples, but even that was a lot of waiting around in order to get the correct responses, and you have to throttle the API a lot. But if you're, for example, using something like GPT-4o or Claude 3, maybe you can do the requests without waiting that much as I had to. And you can select a pretty much more larger sample to evaluate. Next, I'm going to be using the Grok client. I'm going to initialize it, and then I'm going to essentially call the API with a single prompt, passing in the model name, and I'm going to handle some of the errors. So you can, for example, have a look at why the model didn't return a completion. Next, I'm going to be using or creating the prompt that we are going to be using to create the predictions. It's going to be pretty simple prompt, given a context and answer to the and a question. And I want this answer to be succinct. I'm going to ask different models in order to get the predictions, and I'm going to be creating this data class, which contains the question, the answer, the true answer, which is going to be taken from the dataset, and the context. And essentially what I'm going to do is to pass a dataset right here, and I'm going to iterate over the dataset with a given model. I'm going to be formatting the prompt that we created here with the question in the context and ask for an answer to the passed in model. So pretty simple actually. And these are the models that were essentially provided by the Grok API, at least the smaller models, Gemma 7b, Llama 3 8b, and the Mixtral model. This is, I believe, the original one, not the latest one. And in this case, I'm going to be creating these predictions for each model, and I'm going to be extracting the predictions. And as you can see, these predictions took roughly 5 to 6 seconds each. These models are very fast from the Grok API, and I'm going to be saving the predictions just in case. So as we've discussed, you can pretty much use a simple evaluation or a naive evaluation technique. So this is my prompt. Consider the question and answer based on the context compared with the true answer. Score how correct the response is on a scale from 0 to 10. Respond with the integer number only. So there is a lot of nuance about this prompt, and as you can see, you can probably try to make this a bit more complex, but this is again a simple or a naive evaluation that you can do. And this is a prediction that we have from the Gemma 7b, as you can see. And for example, on this prediction, the model is scoring the response with a 9, which is very good. We have the answer, which is pretty much exactly the same as the true answer from the dataset. So I would agree with the critique right here. And what we do next is to essentially run this simple evaluation throughout each of the responses. And I'm adding some sleep time in order to not throttle the responses that much. And as you can see, it took us roughly 2.5 minutes in order to get the scores for each of the predictions. And this is a nice table of the average scores. You can see that the Mixtral model, at least on this only 20 examples, so don't make any assumptions about that, 9.15, which is a very high score, then 8.85 for the Llama 3, and then Gemma performed a bit better compared to Llama 3. So even though we are using the critique model of Llama 3 70b, it looks like the Gemma 7b did a better job, at least on these only 20 examples once again. So Next, I'm going to be using a bit more complex metrics that are available from the DeepEval library. And for that, I need to essentially create my own critique model or eval-based LLM. In this case, the implementation is pretty simple. I'm going to be passing in just the model name, and then I'm going to be passing in the predict to the prompt to the predict function that we've already created, and then the model name right here. So I'm going to be essentially initializing this critique model with Grok critique model with the critique, which is essentially WAMA 370B model. And for the metrics, here is a sample in which I'm creating this LLM test case. This is from the last prediction. It needs an input, which is the question, the actual output, which is the answer, then the context, and then the retrieval context. Essentially, these are the same since we are going to be using different metrics to evaluate that. So we have the answer relevancy metric, and here you essentially pass in a threshold which says that this model has performed well with a score of 1 or a score of 0. And we want this to essentially give us a reason why the score was set as this. And then you essentially call measure on a specific test case. And then you can have a look at the score and then the reason. So essentially, this scores perfectly. The score is 1 because the output perfectly addresses the question and provides accurate information without any irrelevant statements. So very good on this prediction. Again, next we have pretty much the same thing for the faithfulness metric. There are no contradictions found, meaning the actual output perfectly aligns with the retrieval context. Great job. So again, this response is very good. And then for the hallucination metric, which is another very important one, at least on this one, the score is 0, which is great because the actual output does not contradict the context and aligns with the provided information. So this is a bit counterintuitive since the hallucination metric should be 0 in order to have no hallucinations. And if you have a hallucination score of 1, this means that the response is completely hallucinated. Okay, so we have a look at some of the metrics that we're going to be using. Of course, you can use a lot more metrics from the DeepEval library. And for the evaluation as a whole, we're going to be building this data class called model evaluation. I'm going to be passing in the model name, the scores that we have, and the reasons for each of the metrics. So what I'm doing here is essentially creating a test case for each prediction for each model. Then I'm measuring each score and adding the scores to the associated list. And then if the score is below a certain threshold or above a certain threshold for the hallucination metric, I'm essentially appending the reasons to have a look at why this model hasn't performed as expected. And then I'm sleeping for some time in order to not bother the API. And then I'm appending the evaluation to the list. So this took a lot of time to complete. And this is a sample evaluation that I got for WAMA 3.8b. You can see the relevancy scores, the faithfulness scores. We have a faithfulness, for example, 0.5 right here. And then for the hallucination scores, we have some ones. And yeah, we have some reasons for relevancy missing and hallucination reasons. So I'm going to be saving this in a pickle file. And I'm going to be having a look at the different scores that different models had. So you can see that Gemma has actually performed flawlessly, at least according to these metrics. This is the response. This is the evaluation report for Gemma. But still, keep in mind, only 20 examples. WAMA 3, we have some lower relevancy compared to the perfect score, some lower faithfulness, and a lot of hallucinations, actually, for WAMA 3. And then on the mixed trial model, the original one, the relevancy was perfect, almost perfect faithfulness, and no hallucinations, or at least on this subset. So Next, I'm going to be creating this report that summarizes the reasons of the model, that does relevancy, faithfulness, WoW scores, and high scores of hallucinations. So I'm going to be essentially using the different reasons. I'm going to be joining them and formatting the prompt with all of this. And you can have a look at the responses. For the Gemma, there are no text provided. I conclude that the model did great. There are no text provided, so I assume the reasons are empty. But for WAMA 3, we have this. The most common reasons for WoW scores are the lack of relevant information, incomplete answers, omission of crucial detail, and hallucinations. The model often failed to provide specific details, ignored important context, and omitted essential information, leading to incomplete or misleading responses. Additionally, the models sometimes provide unclear or partial answers, fail to address the input question, or included irrelevant information, resulting in a significant mismatch with the context. So you now have essentially a paragraph that tells you what type of errors, at least on your dataset, those models are making. And then based on that, you can take a decision or make a decision on what your model should be. So this is it for this video. You've now learned how you can essentially go a bit deeper than a simple vibe check for different models. And you've seen how you can build a test suite with a set of metrics that can tell you how well particular model is going to be performing on your custom dataset or projects. Thanks for watching, guys. Please like, share, and subscribe. Also, join the Discord channel that I'm going to link down into the description. And I'm going to see you in the next one. Bye.